things, guys, here. Students, you can help me with. Okay, I wanted to draw. Okay, do is probably I'll open up a Word document and then draw a line if I can't find a line here. Give me. Okay, there you go. So let us say I have a this text box, quick word art. I'm looking for lines, guys, just plain white lines, and I'm not able to find the lines here. Let's see table. Give me a second. I'm trying to find where the no, I'm in insert. I know why I'm not able to find the lines. Give me 1 second. Okay. Give me 1 second. How come the lines are cross-reference, hyperlinks, smart art, shapes? Okay, that's fine. Yeah, there it is. See, sometimes, when that's why I always need my cup of tea next to me. I just actually, it was. Draw a line there. I will draw another line. So difficult to draw lines here, right? But I will try to do that. Actually, no, you know what I will do? Okay, here is what I'll do. I'll actually use a table and then we'll create a interesting situation here for you. This is fine. We can do it with a table also, okay? So if I have a table like this, imagine these are all lines. You're able to see my things, right? 4, 5, 6, 7, 8, something like that, right? How many? 1, 2, 3, 4, 5, 6, 4. So this is 24, right? Okay. Students, when I ask you some questions, you can ask, take the help of your faculty members, put in chat, or you can go to the computer and chat. Okay. Imagine each of these numbers, 1 to 24, represent Chinna table is the better, but it's okay. We'll take this, okay? And let us say this is one is Kakinada, okay? 2 is Vijayanagaram. Okay. Somewhere here it's Hyderabad. Let's call it Hyderabad. Jntuk Kakinada is all Andhra, right? Okay, but it's okay to put Hyderabad there, okay? 24, okay? So you have all these destinations here, okay? Now, let's assume the distance between Kakinada and Vijayanagaram, ante? Remote control right now, but I'll give it to you after a few minutes, okay? So hold on a second. Okay, Naresh? Okay. So destination, okay, let me zoom it up so that way you can see that, okay. So from 1 to 2, I will say destination takes 2 hours to go there, okay. And from 1 to 7, you have to fill out all the destination times. So going from 1 to 2 takes 2 hours. Let's say 2 to 3. takes 5 hours. Okay, and 3 to 4 takes 7 hours. Okay. Okay, let me do a better drawing here. Give me a second. Whatever we do, we should do a good job of it. It should not be sloppy. Okay, let's do a perfect job. I'll do a simple 3 by 3 table. Okay, much easier to. Are there. Okay, so what I'm going to do here is I'm going to insert a text box here for you with a number. I'll simply take a normal text box if I can do it. Give me a second. Insert text box. Okay, more text boxes. Draw text box. Okay, let's say I draw text box there. Okay, I'll say going from. Say, how would I say that? I'm not getting the right picture today, but hold on. I think we'll just follow this one. 1 to 2. This is 1. This is 2. This is 7. 8. Faculty members who teach data structures and algorithms, you'll know what I'm trying to do here. So I'll say 1 to 9, right? Okay. 1 to 2 takes 2 hours. So let me just put that 2 going from 1 to 2 as 2 hours. 2 to 3 takes 5 hours. Okay. 3 to 6, because I'm going from 3 down below. 3 to 6 takes, let's say 8 hours. Okay. And 6 to 9 takes 1 hour. Okay. One hour. 4 to 5 takes 2 hours. I'm just shortcutting the thing here. 5 to 6 takes 3 hours. And 6 to 9 takes 1 hour. Okay. So what am I doing here? Basically, I'm showing you how many hours it takes to go from one place to the other place. That is what we are doing here. Nothing more than that. Got it? Now I want you to tell me say what is the shortest path that I would take to go from 1 to 9. Okay. So let me put that in the whiteboard here for you in case. Okay. So let me go back to stop sharing and bring up the whiteboard here. Okay. Actually, whiteboard lo inka easy ga cheyachemo. So question is, how do you destinations, and you have to start at some starting point and then you have to go to the ending point. Okay, what is the shortest path that you would take is what we are trying to achieve here. So who wants to answer that question? Who wants to volunteer? Put it in chat before I pick somebody. Content not visible, please increase. Okay, I did the increasing, right? Or this one, let me increase it too. Okay, you are able to see it now? Okay. Okay, A to B. I'll continue to draw the line. I'm just drawing some lines. So I'm waiting for a volunteer. Okay. Okay. So who is going to volunteer? Anyone coming forward? So I'm just typing here. See, this is my first destination. This is my second destination. This is my third destination. So it just took it away. Okay. So the value here is I'm saying it will take 2 hours. Here, if I say 3 hours, whatever, it doesn't matter, right? You get the idea. So how do we solve? Since I did not get volunteers here. Somebody here. Let's say I pick somebody from some new college here, Sri Sivani College of Engineering. I can't see video and ikkada. I think because of the low bandwidth, the video is not shown. Is there anyone in from Shivani College in the classroom who can answer this question? I think I'm audible now, right? Okay. 145 Chaitanya. Okay. 1569 total cost. JNTU we already answered it. Total cost is 7. Chaitanya answered it 14569. Somebody used private there, principal underscore HM. So you owe me $1 ND because you should put it in for everyone, not private. Okay. So one time I'll excuse you. Put it try the same thing again, putting it to everyone. JNTUK, everyone is getting it perfect. So easy to solve that, right? By looking at it visually. Out of these people, your video is not being recorded. Because the reason it's not being recorded is what happens is the WebEx automatically, when the bandwidth is low, it turns off the video, my face. Okay. Now I see video for everyone because it took care of the bandwidth issues and it's showing everything, right? So this is a very classic problem, by the way, right? It's so easy to do it, but imagine if it was 1,000 by 1,000 nodes that I gave you. How would you solve the problem? Here I just gave you a simple 3 by 3 matrix, right? So I sleep unless you write a program. My question is this, okay? You calculated this path, this path, this path, okay? Very quickly and you did that. So I'm asking some students to tell me how would they track that? What is the algorithm? What is the step-by-step process that they are trying to have to solve this problem is my question. Students, you understand the question, right? It was so easy visually to simply go through each path, right? But imagine if they were and I'm trying to determine how we get to that. Chaitanya, the boys in the front, are you guys able to hear me? You can put it in the chat if you have difficulty hearing me. Okay. Anyone has difficulty hearing me, please put it in the chat. Okay. Okay. So as Chaitanya pointed out rightly here, right? Guys like Prims and Kruskal's and Dijkstra's, they all came up with these wonderful algorithms. But the most famous scientist of all, or engineer of all, if I want to say engineer, who came up with an algorithm for this to solve that problem. Okay. It's called the traveling salesman's problem too. When you have these sales guys like in Andhra, you know how these guys, salespeople, the medical sales representatives, they go from one town to another town, giving those medicines to the doctors and all that, right? So when they have to travel, they want to take the shortest path. Now in that case, in their case, the shortest path is important because they are going to save money, right, in travel. Correct? Computers and that. And okay, let's take the step, just the first step, not even the full solution. What is the first step? You are a computer program. What is the first step? You are in your programming language. Your professors would have taught. I wonder if they are able to hear me or not. Smile if you hear me, or put a unhappy face if you don't hear me. Okay, you are smiling means you are able to hear me. Perfect. Good. Okay, so pseudocode. Okay. Aditya, I'm able to see your picture there. So raise your hands if you know what pseudocode is. Raise them higher. That way I can see it clearly. Okay, I see one student raising the hand in the front. Do you know what pseudocode is? Okay, good. You're raising hands. Now, so I'm asking what, in terms of pseudocode, later on we'll accelerate the speed because I expect students to get things just like that easily, right? Initially I go slow on purpose because I want to make sure you're putting your thinking hat there. Okay, so what is step number one? Let me see, maybe somebody put it in the chat. Let me monitor the chat. Okay, nobody put anything in the chat. So if somebody wants to speak, Chaitanya, is your audio working properly? Do you think you can, if I unmute you, would you be able to speak? Let's try, okay?
Sir.
Okay, I think, oh, go ahead. What is step number one? I'm going to make students become excellent presentation guys by end of the term. Let there be no doubt in your mind. You don't be shy. What is step number one? Begins with comments. Fantastic. Thanks for saying that. I will take that, but you got an easy one. Okay. I will put it as what is the real step number 1? Ignoring comments. Remember, we are all hackers now, right? So I want to hack the code. Let's assume that I want to hack the code. What is my step number 1? You took programming languages, guys. Anything that comes to mind. You have to do something, right? You can even say I have to open up my laptop in Java and open up my IDE, say something, right? Never be shy. Okay. I don't know what my step number 1 is. I will probably initiate a starting point. Can I say that? That means I'll probably have something like a variables, right? So that means I say starting point. Got it? What is the starting point value? Come on, that's a 1 second. 1. We started from 1, right? Remember? 1 is for whatever, Kakinada, whatever, right? Got it? Okay. 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 Then what do you do? Okay. Then what do you do? I think all faculty members, I'll reiterate one more time, bring a bag of nice chalk. Any student who answers a question, they'll be given 1 candy. Okay, here I do that. Okay, Chaitanya is trying to answer something, but they are muted. Let me unmute them. Okay, these 2 guys are very enthusiastic. Okay, tell me your name, the guy on the right. What's your name?
Surya, sir.
Say it loudly.
Surya, sir. Surya.
Surya. Okay, and the guy on the and the guy on the left.
Shiva, sir.
To your right.
Shiva.
Ni parenti.
Shiva, sir.
Shiva. Surya and Shiva. Okay, good. Got it. Got it. You look enthusiastic. So what is step number 2, Surya? What is step number 2, Surya? So you just initiated the starting point. Agreed. Perfect.
Find out the shortest path, sir. Hello.
Each of its neighbors. Can I say something like that? Surya, do you think I can say something like that?
Sir,
Not able to hear me. What about others? Okay. Can you hear me now, Surya?
yes, sir. Yes, sir.
Okay. So is step, by the way, Jntuk put everything there. Check the adjacent nodes and their distances. Exactly. You got it. So Jntuk said, check. That's what this is, right? Calculate distance to each of his neighbors. Okay. Then when you calculate the distance to each of his neighbors, you have to somehow save, store, and all that, right? We'll come to that in a second. What is step number 3? After you calculate distance to each of the neighbors. path between the neighbors selected. Correct? Perfect. Okay, Jntuk Kakinada is on a roll there, but hold on. I want to give chance to others too because you motivated them now. Okay, let me do that. So when you do that, what is the interim step there? When, let's say, from 1 to 2 in this here only, I will draw that one. Okay, let me draw an arrow here. Okay, the arrow ide kada. Okay, let's see. Single arrowhead. Okay. Okay, and then I will draw one more arrow from A to, let's call it, say, D. And the value here is 1. Got it? So you will say A to D is the shortest, correct?
Yes, sir.
So then if you know A to D is the shortest, then what is step 4? Fact.
The neighbors for D, sir.
Reset the, yeah. So that means first you have to then say the next, after the starting point, what do you want to call? Reset the, what do you want to call it? You save the shortest neighbor. That means you should save it somewhere, right? Correct. So that means somewhere here you should know that from A you are going to D, correct?
Yes, sir.
Okay, then what is step 5? For D, okay? Let's assume I'll draw a line here, okay, for clarity. Okay, let's say the neighbors for D are, I'll put like that. I'll put E there. I hope rest of the students are following too, okay? And I'll say for the sake of argument, I have one more neighbor, let's assume that. Okay, and then I'll call it F. What happens if I simply choose 1 here? And let's say I choose 1 here for D to F. Okay, I check the neighbors for D. You can pick either one, right?
Yes, sir.
Correct? Okay, let's say you pick either one. So I'll write the steps here. Step 6, let's say you pick either one. Pick the shortest, right? So check the neighbors. So pick the short. Let's say you pick E. Let's assume that. Okay. Now after you pick E, I'm just going to wrap this up very soon here. Let me put just one more here. Arrow from E to, I'll call it G. Got it? And then I'll draw one more arrow here. F to G is let's say 9. And to complete the analysis, let me put from B to E is let's say 2. Okay. So you got it? Okay. Now from E to G, you have to, the goal is to go from A to G. So if you pick E, from E to G, there's only one path, right? Step 7. So then you go to G from E, right? Yeah, going from E to G. And I'm saying E to G is 21. Sorry. From E to G, correct. Go from E to G. Add up the steps. You went from starting point 1. That's A. From A to D, you did 1. And from D to E, 1, 2. From E to G, 21. 24, and 20, 21, 22, 23. 23, right?
Yes, sir.
Got it. Now imagine if you did not choose E after you went to D, what happened if you chose F?
F, sir.
Then the path would have been only 11, right?
Yes, sir. Yes, sir.
So you see the problem with this algorithm? Right? Is it really only the neighbors, or somehow you have to keep track of the neighbors of the neighbors? Right? It is called looking ahead, right? Okay, you are able to hear me. Okay. Okay, I'm pausing here for a second because there are a lot of students. I want them to ask me a lot of questions. Okay, Aditya, let me ask Aditya. Do you see the problem here in the example? You can raise your hands if you see a problem. Right? Simply looking at the neighbors and following that is not going to help us, correct? No. By the way, it's an extremely interesting problem. And to inspire you, let me tell you one thing. Dijkstra solved this problem. He just had an idea while having a cup of coffee in something like Starbucks in those old days. He's a Danish guy, right? He had some coffee place. On a sheet of paper, he solved this shortest path. This is called the shortest path problem in 15 minutes. 15 minutes, okay? He came up with the algorithm in 15 minutes. On top of it, somebody coming with an algorithm just like that in 15 minutes, it's not exactly an easy problem to solve. But the entire networking, routing, all the internet, everything that we talk about, all the network, routers, switches, and all that, they all rely on Dijkstra's OSPF, we call it, open shortest path problem forwarding. Okay. The goal in this class is for you folks to solve this problem. Take a group of nodes, assign some values like how we did that, and that is going to be a programming assignment for you, how you solve it. The trick is for you to, when you submit it, the trick is for you to explain it in terms of pseudocode. Got it? So anyone can get code for anything today. Okay, you just Google up, you get it. That's not an issue at all. I welcome you to do that, right? But I want you to explain through an algorithm or through a, what I call it as a flow chart. How many of you know what flow charts are? Okay, raise your hand if you know flow charts. Okay. So problem in high school. They did C programming language in high school, and here we learn programming very fast, right? Sooner in schools. I'm sure even in India they're learning programming in schools now. Okay, so this was a problem that was given to them that they had to solve. There are variations of it. Even now they tell me, Papa, that was a brilliant problem that was solved, right? By Dijkstra. It is that good. Now, how much time do you think you need to get? How much time do you think you need to get for this assignment? I think a 1 week time is good enough. How about I give you time? I want you to explain. So here is the assignment for you, right? Let me write it clearly for everyone. Dijkstra. So when you execute Dijkstra shortest path algorithm, you have to take a sample space, okay? Like nodes, like how we did a 3 by 3. Some people can do 4 by 4 and so on. Okay. So execute the shortest path algorithm, draw a flow chart of the algorithm, and your code should have comments. Okay, so that is the, and due, when is it due? What is the date today? 12/16, right? So if I look at next Thursday's class, that will be 23rd, and I'm sure you close for Christmas. Do we have a class on Tuesday 29th, Chakravarti garu? Okay, is that all clear to everyone? Any questions from JNTUV, ASET, Chaitanya, Gopi Krishna, GIET? I see JNTUV, as always, I see a full class. JNTU Kakinada. By the way, JNTU Kakinada, from next class onwards, I want all the students to be occupying the front benches. Okay. So I don't want you people sitting in the back. I want the front row seats to be filled up.
Okay, sir.
From
Okay.
next time.
Okay, sir. Sir,
Okay.
Dr. Chakravarti sir is not available now.
No problem. No problem. This is for the students, right?
Sir will confirm you, sir, on 29th class actually.
We are in vacation.
Actually, we have only the 25th only we have holiday, sir.
Okay,
all other days are working days only.
Okay, got it. Okay, good. GIET questions.
Thank you, sir. Thank you.
What does GIET stand for?
Godavari Institute of Engineering and Technology, sir.
Okay, got it. Godavari Institute of Engineering Technology. Is it a co-ed? I see. Yeah, I think it's a co-ed institution. I think, right? Yes, do you have any questions on the assignment? By the way, when I ask these things, I want you to have an enthusiastic response, right? You can jump up and down, or you can show that you're. Okay, అక్కడ ఇన్స్ట్రక్టర్ ఫ్యాకల్టీ మెంబర్ కూర్చున్నారు కదా ముందర ఎవరో? Let me put a faculty member on the spot here. Is there a faculty member in Gopi Krishna classroom there? Okay, probably not. Let me ask JNTUV. Do you have any questions? Do you understand? Oh, just when I asked the question, they turned off the video. Now I can't see them. Very strategically turned off. Okay. No, I'm just pulling. I know JNTV, they are very super sincere. They are. Okay, let me go to SVECW, All Women's College, right? Is there a faculty member there today?
Yes, sir. Yes, sir. Good morning. I am Dharmaya Davarpalli, faculty of Design and Analysis of Algorithm. Yes, sir.
Okay.
We are here.
So, నేను ఇచ్చిన క్వశ్చన్ ఇక్కడ అందరికి వాళ్ళకి అర్థమైందా? Okay. So, is my assignment a fair assignment to the students?
Yes.
Or is it too tough or too? Okay, yes, good to know that, because I just want to be sure.
Yes, sir. Thank you.
Sir? The only way you will all learn in this class is by doing stuff. I already gave you one assignment last week.
Yes, sir. Sir.
Good afternoon, sir.
All the faculty members in the respective colleges, you have to keep them honest. Okay.
Yes, sir.
Good afternoon, sir.
We are able to hear you.
Okay. Actually, when I read about the Dijkstra algorithm,
go ahead.
I found that Dijkstra algorithm will not work for negative weights. Dijkstra algorithm will not work for negative weights. So how can I graph contain negative weights, sir?
Because what happens is, let us say To go from one place to other place, there's a bridge. Okay, the only way to go from one place to other place is a bridge that you have to cross. And when you had all these big tufan and all that, right? The hurricanes and all that, some bridges collapse. Okay,
Yes, sir.
so I'll
Yes, sir.
put a negative there to say that there is no route. It's temporarily unavailable.
We can
Okay,
indicate
that
that
is
to
how I
infinite
give the
also, no,
meaning
sir.
to them. But for the purpose of this example, don't worry about negative weights. Correct. Yeah, you can. You can indicate to infinite.
Negative weight has any particular specialty compared to infinity, sir?
What does that negative weight actually indicate, sir?
To me, negative weight to me from a practical software development perspective, let's say if I'm doing this one, the moment I use a negative weight, that is just a notation to say that that path is not available. That's it. You cannot take that path for whatever reason. That's all a negative means to me. Okay. Now, I wouldn't say that to a pure mathematician, because for a you are software engineers, we are not doing theoretical knowledge there, right? To me, negative means what? You cannot you cannot gain time. See, for a mathematician, you can gain time. Going from A to B, you can gain time. Agreed? If I apply Einstein's theory of relativity theory, to me, negative basically means I'm doing a time travel going back. Okay, I can
Yes, sir.
argue like that, but it's all useless in a regular programming world. Got it?
Yes, sir. Yes, sir.
Because when the very concept and there has to be some quantum of time. When you have a quantum of time, time is one time. Seeing it, and having a question. In the previous class, whenever things, comment on these things because you're all okay. Let me also show, let's see a few more things. How many of you have already joined the community? Let me share, and I'm sharing my screen here. Loading takes time. Let me go there. I'm assuming you're able to see my screen. Give me a second once I go there. I want to go to groups. Analysis and design of algorithms. So if I go here, that is impressive. 16 is not good enough, right? So I want all students, let me go back here. Everyone must be in the community by next Tuesday. Okay? By next Tuesday, every single person who is attending the class, including the faculty members, should be in the community by next Tuesday. Okay? And you know how to log in. Structures and algorithms. Okay? So I have somewhere here I had the see all these things that I'm showing you here. These are all the solutions, practice problems. Let me open that up. I'm going to post all of these things there for you. Okay. Unless you join the community, you would not be able to get hold of the material. So I get hold of the material. Today you should be there. And I hope to post all of these things by Friday. See all of these things I'm going to post.